we know that the velocity time graph here is circular in nature, which means it should be of the mathematical equation x minus a the whole square plus y minus b the whole square is equal to r square. And if this is the origin here, x minus 0 square plus y minus 0 square is equal to r square, or x square plus y square is equal to r square, right? So, as we did for the previous case, the one with velocity displacement graph, we'll also try to understand the dimensional consistency here. So we have velocity, which is meter per second, and time, which is second. So velocity square would be meter per second square, and time would be second square. And since they are not the same, this equation in itself is dimensionally inconsistent. Therefore, this circle cannot represent a physically possible system. Okay. Now, there is another aspect of this graph here, which is something we should discuss in detail that I'm not going to do here. Instead, I will do it in detail as a different solution because we need to understand the vertical projectile motion, not just a projectile motion, vertical projectile motion in particular. So there's an, some of us might actually think in vertical projectile motion at the same displacement or at the same, at the same displacement, two possible velocities, one positive and other negative, are possible. I mean, two velocities, one positive and one negative, which means one positive on the way up going up and the other negative on the way going down at the same displacement as possible is a, is a reasonable thing to argue here. So I don't want to go into the detail of the vertical projectile motion in this solution. We will do that right after we finish all the options here, which means including option D, the graph D. Okay. So hold your thought for a while and we will discuss and make sure that you get your concepts really clear. And what I'm trying to do is I'll take you through a practical case, a practical example, and then we'll draw the displacement time graph. We'll draw the velocity displacement graph and the distance time graph, and then see, which kind of graph do we get. Now, having said that, in this graph, it is very clear that at t is equal to 2 seconds, the object has two different velocities, one which is v2 and the other which is minus v2, plus v2, minus v2. Now, this violates that v of t must return one value for each time of t. Okay. Trying to explain the same using the mathematical equation of the curve here, we have t square plus v square is equal to r square. How? Because x square plus y square is equal to r square from that. So x is time, v is displacement y. So we have t square plus v square is velocity. V is velocity y. So t square plus v square is r square, and therefore v square is equal to r square minus t square, and v is therefore plus or minus root of r square minus t square, which actually gives us two values, which is plus root of r square minus t square and minus root of r square minus t square. Okay. Now, like we said in the previous concept, that regarding the validity of pointing out that these are negative values, t is equal to -1 and t is equal to -2. Now, t is equal to -1 and -2 doesn't mean the absolute meaning of time. It actually means that the observation started at exactly t is equal to 0, and the actual motion was even taking place before t is equal to 0. Therefore, t is equal to minus 1 and t is equal to minus 2 represents the actual motion that started much earlier. Okay. So this was something that we discussed the previous one graph earlier as well. So we have at t is equal to 2, the actual time is 10 a.m. At t is, oh, this is not 2, it is minus 2. At t is equal to minus 1, the actual time is 10 a.m. Or I would actually say, to understand this better, time on the clock is 10 a.m. Time on the clock is 10 a.m. Time on the clock is 10 a.m. But time on the stopwatch, right? The stopwatch here, that stopwatch now says time t is equal to 0, which means it is now that the actual observation has started. So 10 is equal to t is equal to 0 actually means the absolute time as 10. Well, I shouldn't be using the phrase absolute time. That doesn't make sense physically. So the the time on the clock was 10 a.m. and the time on the stopwatch is t is equal to 0 seconds, where the swing is already in motion. And at time t is equal to 1 seconds on the stopwatch, the time on the clock is 10:03 a.m. and the swing has reached the right extreme. Okay. Right. So this is what I wanted to share you the with the velocity time graph here. So we discussed the concept, we discussed the written part of the mathematical equation as well. And yes, don't worry, I'm going to take you in detail for this one, the vertical projectile motion and how to calculate those values. Okay. Right. So now moving on to graph D. So what we'll do is we'll discuss graph D first. We'll understand the concept and the solution, and then we'll come back to vertical projectile motion. Okay. Let us finish this question first. Yeah, this is, if you want, consider this as an optional explanation. But see, um, when you say if you want to make that optional, what I'm trying to, what the whole purpose of this series here is to make sure that we try to make the maximum sense out of each and every question, every option as well. Okay. So when you say that, okay, we have done 3 graphs and the next is the 4th graph, and we just skip the optional explanation part for this vertical projectile motion here, what you're trying to do instead is you are trying to skip a concept which is very significant. And it is not out of topic or not out of context, because we are talking about something which is very close resemblance to the given graph here. And therefore, it becomes relevant as a potential source for the future questions. So, yes, very humble apologies that I'm making you work a lot on just one simple question. But it is not that I'm trying to elaborate every possible options. But whenever it's necessary, I'm afraid I have no other options than to do it. Okay. Please, I really appreciate. See, if you have been following this solution so far, and if you've been writing notes along with me so far, that's the kind of practice we're talking about. That, that habit of not skipping one, that habit of writing down and following every solution, that will slowly build a habit which will make your concepts grow strong. Okay. So please bear patience with me. Let's move on to the next graph.